Right, a quick video on factorising trinomials. This is a method I quite like teaching. Trinomial, of course, something along the lines like this, where you have got your variable x, and you have x squared, then you've got some x's, and then you've got a number on its own at the end, a constant added on. And to factorise this, remember factorising means you're basically trying to put it back into brackets. Now, the method I like using hinges on you being able to take out a common factor. So by that I mean, if you've got a statement like this, you know you can take out a common factor of 2 and be left with x plus 6 in the brackets. You also need to be able to take out a common factor involving letters. So let's say 6x there. So again, you'd be going the common factor of 4 and 6, that's 2. But then remembering I've got x squared and I've got x, so I could take out a common factor of x, leaving me with 2x minus 3. Of course, it's always good practice, good idea to multiply back out your brackets. 2x times 2x will give me my 4x. 2x times minus 3 gives me my minus 6x. So long as you can do this, you should be able to factorise a trinomial. First one, I've got k squared plus 9k plus 20. A lot of people tend to use the trial and error method, where they just get a pair of brackets and start putting things in. And that does work, but for more complicated ones, like the ones I'm going to look at later, that method sort of falls down. What I'm going to do is I'm going to take a slightly longer route, and I'm going to look at this 20, and I need to ask myself what two numbers multiply to give me 20 and add up to give me 9. So very little thought there. I know I've got positive 5, positive 4, or 4 and 5. So I'm going to rewrite my statement as k squared plus 5k plus 4k plus 20. Now it's important to realise, well, my k squareds, they've not changed. My plus 20 here, it's not changed either. And really this 9k plus 9k hasn't changed either, because positive 5k, positive 4k, when we combine those, it gives me 9k. Now, what I need to do is I need to take out a common factor. I'm going to take out a common factor of this first set here. So k squared plus 5k, got a common factor of k. In my bracket, well, k times k would give me k squared. K times positive 5 would give me 5k. I'm then going to do exactly the same with the second pair. Plus 4k plus 20. Common factor of positive 4. So that would leave me with k plus 5. Now, here's the important bit. I've got exactly the same bracket occurring twice. So really, what I can do here is I can take out another common factor. I've got a common factor of k plus 5. What have I multiplied k plus 5 by? Well, the first time I've multiplied it by k. The second time I've multiplied it by positive 4. Quick check. So you should be doing this mentally whenever you factorise something. K times k would give me k squared. Positive 5, positive 4 gives me positive 20. That would multiply to give me 4k. That would multiply to give me 5k, which adds up to give me that. So we can see we've factorised that completely. Next one, negatives involved, but the same process. I need to think what multiplies to give me positive 28, but adds to give me negative 11. Well, straight away I know 4 and 7 multiply to give me 28, but they add up to give me positive 11. So, thinking carefully about this, I need to introduce some negatives. I know negative 4 and negative 7 will multiply to give me positive 28, and they'll also add up to give me negative 11. So, x squared doesn't change, my plus 28 at the end won't change, but I'll replace my negative 11x with negative 4x, negative 7x. So, first pair, taking out a common factor of x to give me that. The next pair, now we need to be careful. I could take out 7, so if I take out positive 7, I would be left with this. And the problem here is that my two brackets, I do not have a common factor here, so I can't go any further. So I need to think a bit more carefully about taking out my common factor here. 7 didn't work, so if I could take out negative 7. That would leave me with x, because minus 7 times x gives me minus 7x, and minus 4, because negative 7 times negative 4 would give me positive 28. Now this time I've got my common factor. So I can take out my common factor of x minus 4, and I'll be left with, well, what have I multiplied it by? X minus 4 has been multiplied by x in the first case, and minus 7 in the second. Again, quickly multiplying out, x squared plus 28 minus 7 minus 4, well, that tidies up to give me minus 11. Now, this is where it starts to get a bit trickier. Looking at this, I'm asking myself, well, I've got plus 1 at the end, so something times something gives me 1, adds up to give me 4. The problem there is I don't. That doesn't work. 1 times 1, that's the only thing I've got for that. 1 plus 1 doesn't make 4. And this is where the magic number, this I call it, comes in. You need to look at this here. You've got 3y squared, and you've got the plus 1 at the end. To get this so-called magic number, you need to multiply these two terms together, those two terms. So 3 times 1 gives me 3. So I'm looking for something that multiplies to give me 3 and adds up to give me the 4 in the middle. Straight away, 3, positive 3 even, and positive 1. They multiply to give me 3 and add up to give me 4. And then it's the same case as before. 3y squared plus 3y plus 1y. I tend to put the plus 1 in when I'm doing this, as it makes it a bit more obvious what my common factors could be. And factorise. So 3y in common there, be left with y plus 1. Now, I have got a common factor of 1 in my second pair, and normally you wouldn't take that out. But to help me with the final step of taking out my final common factor, I'm going to take out plus 1 here, and that'll leave me with y plus 1. Again, I've got these matching factors, a common factor yet again. So I can take out y plus 1. What's it been times by? It's been times by 3y in the first case, and it's been times by plus 1 in the second case. Multiplying out, again, should always be doing this. 3y squared plus 1, 1y and 3y give me 4y. I tend to prefer this method of taking out a common factor for these types of problems rather than just trial and error. It is possible to solve this with trial and error, but with the next one I'm going to show you, trial and error really falls down.